Today we're going to talk about estimating square roots in the final lesson of the first part of Unit 1. So to start, we're going to do a little recall section, and we're going to talk about the difference between square root and squared. So we want to remember for square roots that we include the square root symbol in the answer when the number that we are taking the square root of is not a perfect square. Not a perfect square. And we want to leave the answer as a whole number. So an example of this would be like if we had a final answer that said the length was equal to the square root of 7, we would leave it as the square root of 7 because we know 7 is not a perfect square. That's also the same for numbers like the number 5. We would leave the square root of 5, or the number 21, or any number that's not a perfect square. Okay? We do not include the square root symbol in the answer when the number that we are taking the square root of is a perfect square. So is a perfect square. So if it is a perfect square, we will solve it and we will drop the square root symbol and we'll find the square root of that number. So for example, if we had an answer that said the length was equal to the square root of 25, well, the number 25 is a perfect square because I know that 5 times 5 equals 25. So I would say my final answer equals 5. So when it is a perfect square, we solve the square root and we drop the square root symbol and write out the actual square root. Okay? When we think of the squared symbol, we're going to think about it as we include the squared symbol in our answers when speaking of area, but only after the units. Okay? That's very important. So a squared symbol after units. So the units could be centimeters, just the word unit, meters, any unit of measurement, indicates that we are speaking of an object that is two-dimensional, or we're talking about the area. Okay, so an example would be if we had a square that had side lengths of 3 times 3, we would say that the answer is 9 units squared. Okay? Now, we want to make note that 9 squared is not the same as 9 centimeters squared, because if we have this 9 squared in front of us, if we write out 9 squared as our answer, that's really saying our answer is 9 squared, which is 9 times 9, which equals 81. Okay? 3 times 3 does not equal 81, so we want to make sure that we write our unit of measurement and then the squared symbol. Okay? It says for the next part that we do not include the squared in our answer when speaking of length. Okay? So when we're talking about just a line segment, we don't do that because the length of something is only one-dimensional. So if I'm trying to find the perimeter of, say, that same square that had side lengths of 3, well, I would say that's 3 plus 3 plus 3 plus 3 because I know that there's 4 sides to a square, and if it's a square, they're all the same. So 3 plus 3 is 6, plus another 3 is 9, plus another 3 tells me I would have 12 units as a perimeter, but they are not squared because it's simply a lineal measurement. It's not two-dimensional. It's not an area. It's just the outside perimeter. Okay? All right. So very important stuff to remember. So for our investigate question, it says, using a number line, estimate where each square root may be placed. And this is kind of the heart of our lesson today. We're trying to estimate where non-perfect squares could potentially end up on a number line. Okay? So this gets kind of tricky, but to do this, the first thing I'm going to do is I'm going to lay out a number line that has some whole numbers on it. Okay? So I'm just going to start on the left side of my number line. I'm going to say that 0. I'm going to say this is 1, 2, 3, 4, and 5. So I'm going to lay that out just like so. I put my whole numbers on the bottom. Okay? Now, what I'm going to do is above these whole numbers, I'm going to write kind of the perfect squares that associate with each number. Okay? So I'm going to start with my number 1 because I think that's the least confusing maybe. If I think of the square root of 1, well, it is 1 because 1 times 1 equals 1, okay? The next one that I have for perfect squares would be the number 4. So we've got 1, then we would have the number 4. That's a perfect square because 2 times 2 equals 4. So since that lines up with the number 2, the square root of 4 equals 2, I'm going to put that just above the number 2. Well, my next perfect square is 9, and I know that because 2 times 2 was 4, which means 3 times 3 is 9. So the square root of 9 equals 3. So those line up on the number line. The next one would be 16. The square root of 16 equals 4. And then I would have 25. The square root of 25 equals 5. Okay? Next, it asks me to use this number line to place or to estimate where each square root may be placed. Okay, to do this now, I'm going to take a look at my first one here, which is the square root of 2. Since I have the square root of 2, I'm going to try and kind of ignore my bottom whole numbers right now, and I'm just going to look at my perfect squares on top, okay? The square root of 2 has got to fit somewhere on this number line, and if I take a look at it, I have a feeling it's going to fit somewhere in here, because it's going to be in between the square root of 1 and the square root of 4, and I'm going to say it's a little bit closer to the 1, so I'm going to say the square root of 2 is somewhere around here, which means the number of this, if we were to actually square root the number 2, it would probably be something like 1.25 or somewhere around there. Okay, I'm just estimating right now. The next one is the square root of 5. Okay, the square root of 5 is going to fit somewhere in this window because it's greater than the square root of 4, but less than the square root of 9. It's a little bit closer to the square root of 4 because if we think of numbers, 4, then 5. So I'm going to place the square root of 5 right here on my number line. Next, I have the square root of 18. That's going to fall somewhere all the way over here because it's greater than the square root of 16, but less than the square root of 25. And it's definitely closer to the 16. So this is where I'm going to put the square root of 18. The last one is the square root of 24. Well, that's going to stay left of the square root of 25. So it's also going to fall in this opening. And it's going to be nice and close to that 25 because it's just less than the square root of 25. So that's how we can use a number line and our knowledge of squares and perfect squares to estimate where each square root that isn't a perfect square might be placed. Okay? Below that, we have a connect that says one strategy to estimate the value of the square root of a non-perfect square is to find the two perfect squares that the non-perfect square would be closest to or in between, we can think of it. Now that's just using words to talk about what we just did with our number line above.